Hey everyone. As was stated, we're here to talk about ParcelMap BC, and our incredibly verbose title is a complex way of saying we want to talk about how we get data in and data out of the ParcelMap BC system. I'm Nick Okoski. I'm the systems engineer for the project, and I'm responsible for the technical infrastructure, the hardware and software, so moving data through the system. This is Brian Sowers.
I'm Brian Sowers. I'm the supervisor of operations, and I'm in charge of making sure that 7 technicians are happy working for us. I'm also in charge of making sure that the system's meeting our business needs, and any issues we see get logged and defected, and hopefully we can inject a fix into the system so we can continue on with the project in a successful way.
And I just wanted to say at a high level, what we're really talking about in terms of data in is data in from BC land surveyors, so parcel data into the system, and then out to the customers, which includes BC land surveyors, but many other stakeholders as well. We send it to Data BC. We have BC assessment. We'll have notaries and lawyers, people dealing with real estate. There's quite a large group of stakeholders now involved, and we're coming up on, I guess, FOC, fully operational capabilities, within the next couple months. And yeah, I just wanted to give a nod to MDA as our build contractor doing a lot of the software development, and they're a big part of the project.
Yeah. So what is this ParcelMap BC? Basically, it's a representation of the land base of British Columbia. There's 4 real pillars that we're striving to work towards, and that it's single, meaning it's one cadaster for the entire province. That includes coverage on every municipality, all regional districts, and rural areas. It's complete, so it's an active account of all surveyed parcels in the Land Title Register and the Crown Land Registry. It's trusted. We have defined operations, we have defined attribution, we have specifications for survey plan data sets that are being submitted by surveyors, and we have operating procedures that have been approved and rigorous acceptance tests for both system integration components as well as data integration components. And it's sustainable. So we're talking about a mandate from the Land Title and Survey Authority going forward that we have funding to continue this project. We have a team in place, and the team consists mainly of GIS technicians, but there's also 2 technicians on the team with a surveying geomatics background. Moving forward, we have lots of work to do in improving what we've built, and we have the mandate to do so. So it's going to be sustainable, and the surveying community is on board with the project, and moving forward, their data is really what's going to be driving the change. Challenges, lots of challenges over the past 2.5 years and previous to that as well. We're talking 5 UTM zones within the province of BC that we obviously can't display the whole province spatially in one UTM zone because there's 5 that cover the province. And our work needs to be done in UTM. So, that sounds simple enough. All data sets need to be projected into their equivalent UTM zone. That, typically isn't an issue, but sometimes it's a challenge when surveyors don't necessarily define the proper projection during their submission. 9 survey systems throughout the history of the province that are active survey systems. This is a challenge for us. Most on the team aren't surveyors. And we may have, say, a township survey plan from 1890 somewhere in rural BC, and we have to figure out how to represent that in this fabric. Luckily, we have good support from the Surveyor General Division. Deputy Surveyor Generals are constantly on the line with myself and the technicians providing guidance in this respect. It's an expansive area, almost 1 million square kilometers. This will be, when complete, it's almost complete, one of the largest single cadasters in the world, I believe. It's complex. There's complex coastline, complex geometry associated with many islands, fjords, etc. This has posed a challenge at times with the Parcel Fabric data model itself and some of the COTS tools we're using. We've definitely been pushing it to the limit. We've discovered many bugs, for example, that Esri may not have been aware of. They're the primary platform we're using for the integration component. And certainly working with our contractor through Esri to get these things resolved is one of our ongoing challenges. Millions of features. The database itself is huge. 20 million plus polygons will be in there, 20 million plus lines, 10 million plus points, and 55,000 control points. This will get larger over time. We don't actively delete parcels. We rather make them historic and inactive. So when adding new subdivision parcels over top an old one, that old one won't be deleted. We're going to track the lineage of that history by making it historic. And continual operations as well as the build. That's been going on concurrently for 2 years or so, which has been a challenge. I'll get to the next slide, which shows you where we are spatially in the province, but suffice to say, over 2 years, we've had half our team working on testing new increments that enter our fabric, and half the team integrating data sets at the same time concurrently. Where we are now, this is a great map my colleague made. And the green areas are active areas published in ParcelMap BC. And the gray areas, you can see there's not much left, just really parts of the GVRD are not active yet. So we started at number 1, which was our pilot, which was Nanaimo Regional District. Worked our way south, Cowichan Valley Regional District, Capital Regional District. We finished off the north end of Vancouver Island, and then parts of the interior. Slowly over 2 years, we brought them into operations. GVRD was broken down into 3 subsections. A, which is Delta, Surrey, and the 2 Langleys. They're in full operations now. B will be online, I believe, at the end of the month. I think we're in our final transition component for getting B operational. And B is really anything north of the Fraser, including municipality of District of North Vancouver, City of North Vancouver, West Vancouver, Bowen Island. And at that point, all that will be left is UBC, Vancouver, Burnaby, and New West. And that should be done by the end of June. So the build itself from a data component will be complete TBD by the end of June. That's our target.
So why are we here? Why are we presenting at an FME conference? Well, we have a complex, highly automated system, and we really couldn't be doing what we are doing with it now without FME. We're leveraging it as much as possible. We are learning at the same time. We are not FME experts. I hadn't had much experience until about 2.5 years ago, but we've really ramped up and tried to make as much use as possible of this technology. So really in the full life cycle, what we're dealing with and what we're using FME for is, number 1, fabric acceptance testing. As we receive an increment, so a regional district worth of data, might be 200,000 parcels in one part of the province, we are testing it. So I forget, some 20-something FME scripts that are doing data integrity QC checks. We're running through before we take it into operations. Yeah. So we have to make sure, is the data good? Can we make it better before? What needs to be done? Do we need to reject certain data? Do we need to go back to the source for some of this data? Data submissions from BC land surveyors. I'll talk about this a bit more in a second, but we are getting data in every day. When a land surveyor develops a new plan, they submit it to us through a digital system. And FME is used to convert that data and bring it into us. And that's where we get to data integration by the Parcel Fabric Operations team. So the surveyor submits, operations team integrates, and then through to publication and distribution by our customer-facing services. So this is how we get the data back out. And we definitely leverage FME here. And I'm just going to skip over this part for now. As far as our systems and technology goes, I'll briefly describe kind of a simplified view of our infrastructure. But I'll start by saying we're using the Parcel Fabric data model, a modified version of which we have our own schema built on top. We've got a Postgres backend database, actually several databases, and we're using FME for a lot of the automation, data in, data out. And it all starts with our production Parcel Fabric. We have a database sitting on a server in Vancouver in our office. We found this to be we're originally going to do a cloud-based service here, but with the 8 technicians working, the latency was too high. We needed something really fast, so we kept it in office. The rest of the system, for the most part, is hosted elsewhere. So this is where we keep all our parcel data. It comes in, the technicians are working on it every day. When we accept an increment, it goes into the production Parcel Fabric. Users do not access this database. users access our published Parcel Fabric database, of which we have various copies, but the primary one right now is hosted in the cloud in Mississauga. And this is where they would come to get data through our various services. The first of which is getting the data in through survey plan data set submission. Brian will talk about that in a second, but basically it's using FME to take a survey plan data set plus some metadata, bring it in, and it's going to feed it all the way back into the production Parcel Fabric. Once that's done, life cycle goes through, data gets published, and we're going to serve it out through the first of our services, which is Surveyor Search and Download. This will allow a surveyor to go into a web map interface, search for data, and download it. FME provides the download capability there. We have Parcel Information Search, which is a simplified version of the Surveyor Search and Download product, a web interface for other users who don't need a download component, so we don't use FME here. This is just a display. These are web services, web map services, so you can view and search, and that would allow users to link to other parts of our system. So if you wanted to find a plan, and you wanted to purchase that plan, or you wanted to purchase the title for it, you could get it through our visual map interface. And finally, we have a product called ParcelMap Direct, which basically allows a stakeholder to download a large extract of the Parcel Fabric. So if you wanted one full regional district or the entire province, you could actually use ParcelMap Direct to get that, and I'll describe that in a moment.
How do we integrate CAD data into the Parcel Fabric? That's really the bread and butter of what the Fabric Operations team does. So survey plans are filed at the Land Title Office and submitted to the Surveyor General Division every day by surveyors. And a representation of that needs to be integrated into the Parcel Fabric when those parcels are registered or confirmed. In order to do this, we leverage FME, and I'll get to what that workbench looks like in a second. But our output is something called a survey plan data set, and that's really what it looks like overlaid on some imagery. I believe this happens to be in North Vancouver somewhere. So the survey plan data set itself. Here's a survey plan data set. It's a drawing file. This happens to be opened up into MicroSurvey, which is the CAD platform most surveyors use in the province of British Columbia, from my experience. I certainly haven't used it, so it's been a challenge trying to adapt to using it. I'm more of a MicroStation user, right, Jeff? Survey plan data set submission, like Nick was mentioning, goes through something of a submission portal. So the metadata associated with the submission is attached to the output file, which I'm going to get to in a second, how that works. But suffice to say, the surveyor inputs whatever metadata is necessary correlating to the plan that they're submitting. The data set itself is not only a drawing file, it also includes a control point CSV. So the control points come in through the CSV submission, through the survey plan submission interface. Once everything has been it's staged in the SPS submission component, a series of well, I'll get to those in a sec. Validation routines happen, which FME is running those validation routines in the background. But each surveyor, through their MyLTSA login, can access every single data set that they have submitted or their firm has submitted, and it comes up in a table such as this. So, you know, surveyor X submitted this data set at this date. The status of that data set is therefore visualized in a table like this. What's interesting about this is two things I'll just point on. One, once the data set has been submitted by the surveyor and those parcels have been registered at the Land Title Office, that's really the trigger for the operations team to receive a work item for it and then process it. So there's a latency period there where sometimes a submission may occur previous to the plan being registered. But once it does, the state will change to pending. So the surveyor will know that the data set's pending integration. When it's integrated and ultimately published out, that state will change to published. So they'll be aware of that. If during our component, the operational component, we notice a defect in their data set, we can request a correction whereby the surveyor will be notified of what's wrong with the data set, and the status will flip to defected, and they can correct the data set and resubmit it through this interface. The validation component, which I briefly mentioned before, which is part of the submission process, that's why I mentioned it. is really twofold. I'll go back. The first component is a visualization of where their data set lies. So it's really just saying, is your data set spatially in the correct location in the province where you'd expect it to be? If it is, that's great. If it's not, it could be something as simple as your UTM zone is wrong when you did your submission, you selected the wrong one. We see that from time to time. This is really a warning saying that it's the heads up to the surveyor saying, is your data set in the right location? The second round of validation checks run a series of FME scripts in the background. We have a plan check, which basically says, is this plan associated with this surveyor's commission number? We do control point checks, verifying that the control points are the correct control points associated with the plan. Some topology checks and the like, and some structural tests just saying, is everything we expect in this submission actually present? If not, it'll flag it as a warning or an error, and the surveyor can fix it before submission. So once everything has been verified, and they've digitally signed off on it and submitted the data set, and the subsequent parcels have been registered or confirmed, then the staging script kicks in, which runs on FME server in the background. And this is really what the workbench looks like. So in a nutshell, it's a simple CAD to file geodatabase conversion, harvesting some of the metadata which is plucked as a JSON file from that form that the surveyor fills out when they're submitting their data set. On the other end, out pops line features, polygon features, the control points, and a plan extent, which is basically an arbitrary extent the surveyor defines around their data set. That then becomes a work item that our team receives. We can download that simple feature class. We run through a series of our own kind of processes on that data set, whereby we take the simple feature class, validate its topology, attribute it, which I can show you here. This is what the output file geodatabase looks like in a simple feature class. If it's missing any attribution, we'll fill it out here. We'll validate topology and then load it to something we call a staging fabric, which is basically a mini Parcel Fabric data model that's just associated with that plan submission. At that point, we'll take the staging fabric and integrate it into our master working fabric. And if everything's done in the QA/QC routines on the join pass, then the technician will post that up to our working fabric production database, and it'll be published out.
Cool. So now that we have data in from the surveyors into our working fabric, it's gone through the whole system, which is part of the survey plan dataset submission. How do we get data back out? The first of which is ParcelMap BC Search. We have something called the MyLTSA portal. So it's a web interface that's going to host our web application here. So we have different versions, different web maps for land surveyors because it includes the download component. We have one for other users who might be, we call them enterprise users. They might be real estate professionals, lawyers, notaries, etc. And we're going to have a guest user interface in July. This goes through, you can imagine the licensing agreements when it goes with land administration, ownership of properties and all that. There's some lawyers working on it. But yeah, we'll have a simplified version available for everyone. You can log in you don't have to log in. You can load up the application and view all of the data through our interface. And that's been an interesting one, both from an FME perspective, an ESRI perspective, and just our overall infrastructure, because we need to be able to scale this system to support that. Because if we have, say, is it something like 200 land surveyors in the province? 200, yeah, 200 or 300 land surveyors. Not a big problem to support that many users, but when you start talking, we're going to add enterprise users, so several thousand of those, and then you have guest users, a few thousand more of that. We have concurrency, so we need to scale the system. So we're working with that, working on that right now. And as I briefly mentioned, and we'll detail in a moment, ParcelMap Direct. So this is our web service. So this will allow our stakeholders to get the larger extracts. And the last part, we already have made our data available through the Data BC catalog. It's on the OGL, so the Open Government License. That's been signed, agreed on. It happened in November of last year. So the ParcelMap BC fabric can actually be downloaded now just through Data BC. So you can get the entire province, and we're providing that to them. Surveyor search and download. So how do surveyors get data out? Well, here's a little screenshot of our web application. I've stripped out all the headers in that of the MyLTSA portal just to make this a bit more simple. And I've turned off a lot of the other layers that are available. We're really just viewing here parcel boundaries, and you can see the traditional teal color of selection for GIS. It's remained that way for years and will probably be that way for the rest of our lives. A bunch of parcels have been selected on screen, and then the left-hand pane, the download portion of our tool is open, and the user just wants a CAD-ready download. So we want to select, say, 15 parcels. In CAD format, you want to include parcels, which are lines and annotations. We'll have parcel points, and we're going to have the control points as well. And we're also selecting a UTM zone to go with that. So in this case, UTM zone 10. So we represent all UTM zones. Our core data is stored in BC Albers. So we actually have BC Albers sitting on top of our web map here. So that's how we can display an entire province in one coordinate system on one map rather than have to use different viewers or some sort of other workaround for that. But you can get the data in BC Albers in its native format for the web there, or you can get the UTM zone, which is what a surveyor would generally use to pull out another CAD file. So they can come in, get the data from us, get the download in their inbox, take it, start working on it. If you want to subdivide some parcels, whatever work needs to be done that Brian's team is responsible for, this is their baseline. So they don't have to go back to original source, request data from somewhere else. They can get the latest up-to-date data from our system, modify it based on their new plans, and then resubmit to us. So it all comes through the same portal. So there's no more paper submissions, searching for data from other survey offices, whatever system they were using in the past. It's all just one system, one point of access, one data source. And so that gets back to the pillars Brian discussed earlier. It's one stack of robustness at this point. And there's a workspace that you can't read on the screen anyways. And finally, for ParcelMap Direct, so getting the provincial extracts out, this is a system-to-system interface. There is no UI. It's a REST API, so this user's going to make a call via their system, just using some simple JSON, and they're able to get various information out, and that information is all accessed and delivered through an FME workspace. So the users can request a Parcel Fabric extract, so a regional district, an area of interest by using some GeoJSON geometries, the entire province if you just say, I want everything. We have real-world changes, so as far as our Parcel Fabric is concerned, and Brian mentioned, we have a history. So do we want, a user could come in and say, okay, I want all the changes that happened in this regional district or this municipality in the last 30 days on the ground. What has been subdivided? What has been added? Have airspace parcels been added? Do we have new developments? Do we have new subdivisions? You can get that information and you can define the dates for that back at least to the time in which the project began and the data was there. We can't go back 200 years and say, give me the history of everything. But we can tell you, okay, since ParcelMap BC was active and we had data in the Parcel Fabric, what has changed? We can also deliver spatial improvements. So as time goes on, we are adjusting the fabric. We want to make it more accurate. And this is a problem in many areas of the province. Like we have data from the city of Surrey now, which is near perfect. But some of the data from northern BC that maybe is a few hundred years old, well, that accuracy is maybe within 10 meters as opposed to city of Surrey that's within centimeters.
Yeah, we've seen 50 meters off.
So that's a problem. So we're using some mathematical models to adjust the fabric over time in small spaces, not the entire fabric at once. We basically perform least squared adjustments on the fabric. And if a user has an extract of the data already in their system, say they're someone like BC Hydro, so they want to align their infrastructure to the Parcel Fabric, they can come in and say, okay, how has the fabric been adjusted? How has it been made more accurate in this area? And then they can come in and rather than get a new extract and perform modifications across all of their data, they can come in and say, okay, this has changed, it's more accurate in this area, so we will now just adjust our data in this small area based on the improvements made to the fabric. And finally, we have a pre-generated province-wide parcel snapshot. So every Saturday, we generate the entire province using FME. It sits there, so a user doesn't have to come in and wait anymore. They're just able to come in, immediately download the full province extract. And there's the wonderful workspace here. Again, I'm here to learn about some best practices so that we can further improve our system. So is this too big? I don't know, might be. Yeah, we'll cut it there, and if there's any questions for us, we're happy to answer.
you, Brian. Thank you. Oh, there we go. Thank you, Nick. Thank you, Brian.
Thank you. Cheers.
We still have some time here in the next 5 minutes before they go, because I know there is some burning questions here for these guys. You're not at the hot seat yet, guys. Who's got a question?
What's the toughest part about the topology challenge? The toughest part about the topology challenges with new plots?
Making sure surveyors submit their data sets and they've in clean topology is the biggest challenge. So here's one thing that we have improved over time in reference to some of these FME validation scripts. When we initially, one of the initial components to this project was trying to get stakeholder buy-in, and one of our biggest stakeholders is the surveying community. We wanted it to be a relatively soft landing for them to have to change their process, because now they have to submit this data set. So for a while it wasn't mandatory to do so, and we wanted it to be as simple as possible to get them used to this process. So some of those checks weren't very strict. Suffice to say, when our team goes to kind of do the integration component, none of the topology is being validated. There's gaps, there's overlaps, there's overlapping lines that shouldn't be, stuff like that. So we've had to A, either clean that up as we go, or B, that's when our defection process kicks in.
Thank you for an interesting talk. A couple questions about integration with the rest of the cadastre, such as rights of way, provincial parks, water parcels, other spatial fabric that needs to tie in and work geospatially together.
Good question. So parks, depending on what type of park it is, it may be in our fabric. Usually if it's a municipal park or a regional park, which we actually have the owner type as municipal because there's no regional owner type in our fabric, they should be there. So your local park down the street should be in our fabric and it should be classed as park. Provincial parks, federal parks will be on a separate admin feature layer, which is basically just a simple feature class that we don't maintain and we don't align to our fabric either. Yeah.
Last for the rights of way, major utility rights of way across the province.
They'll, just to premise that a bit, SRWs and any interest really has been one of the biggest challenges, trying to fit them in, not only through compilation, but through ongoing integration. We're going to account for all rights-of-ways, especially over time. We're not there yet. Our source was missing several thousand, so we did a backlog project in the Northeast and Peace River to basically hand COGO. We had a team from MBA coming in and like digitizing from plan thousands of SRWs in the Peace River region of the province. We're still missing thousands as well, so there's ongoing effort to try to get these caught up, especially interests that have charges on them, you know, like with PIDs, for example. That's going to be our first priority, to try to get those in. But from operations moving forward, since I believe it was September 2016, all of these are required to be submitted by the land surveyor, so they will be integrated. Yeah.
Are you taking into account the spatial improvements submitted by local governments since you've started the compilation throughout the different increments?
Since we've received data from the source?
Yeah, so since you got the data from the ISIS cadastre and you took on compilation within a jurisdiction or an increment, are you taking that local government feedback into account? Because since they're delivering it on that weekly refresh?
The answer is no, but maybe we should be, except in one circumstance that I know of. Parts of the Kootenays and other municipalities, when we looked at the data that we brought into our fabric, the curves and stuff weren't represented properly. We call them squiffy curves. That was kind of a nickname derived by our subcontractor. We inherited that from our source. Since then, our source has fixed those, and certainly it wasn't an issue with the municipalities compiling that way. It was them delivering it to our source where there was an issue with the representation of these curves. Since then, they have fixed that. So what we're doing is looking at the cadastre we built, or the fabric we built, looking back at what in this case, most of the time, the ICF had fixed and reconciling that difference. So fixing these quote unquote squiffy curves. But in short, no, we haven't looked at fabric improvements done by the local LGs.
All right, thanks.
Oh, yeah. I'd like to ask if you're going to include the airspace and the water lot in your fabric?
Airspace parcels?
Airspace,
We do have airspace parcels.
Yeah.
They're not yet, we don't have Z attributes on them yet. We have it as part of our schema. But yeah, short answer is yes, we have airspace parcels. We account for them. They're part of the fabric, and in the future, we'll probably actually make it 3D aware.
it's a 2D fabric right now.
My question is when the surveyor is submitting their data, they were submitting a CAD file. Can they be other formats like GIS? And are they also submitting a survey plat? And is that, in the US, the survey plats are stamped, usually in the county courthouse or something. And are you also accepting those? Are those PDFs or a letter or whatever? I'm wondering how you handle that.
Yeah.
Do they have to be a CAD file, digital?
To two parts. First part, does it have to be a CAD file? Yes, always a CAD file. We need a digital file to be submitted through the survey plan submission portal. They are also, so this is part two, they are also required to submit the actual survey plan. So you know, the signed, commission numbered plan associated with the digital CAD file, and that's where it comes into the system where we say we need that file, we need your metadata, and you also have to submit that plan to the land title office. And once that's done, we get a work item, and then we can begin working on it. Before that happens, we're not going anywhere.
To add a little bit to that, right now it's two separate streams, right? So the first stream that was in place since the LTSA submission went digital, so PDF digital, was really they have to submit, well, the plan is filed as a package to the land title office. That has not changed, so we're not disrupting that flow. We're basically adding a secondary stream saying, hey, now you have to submit this survey plan data set CAD representation of that survey plan as well.
Well done, Nick. Well done, Nick and Brian.